In this video, we're going to be looking at the domain of a square root function, basic and advanced. Okay, so first of all, recall that the brackets are used for included values, the parentheses are for non-included values, and for infinity. Also, remember that if you have a negative square root, okay, that cannot be in your domain, right? Because that will give you complex numbers. So whatever's inside the square root must be greater than or equal to 0. Okay. Now, if the square root is in the denominator, whatever's inside must be strictly greater than 0, because the denominator cannot be 0 because you can't divide by 0. So that's how we'll do it if we have a denominator with a square root. All right, so let's take a look at the first problem here. We've got g of x is equal to square root of 8, or square root of x plus 8. Notice that the line does not go over the 8. Okay, so the only thing in the square root is right here. Okay, and it says that we need to set whatever's under the square root greater than or equal to 0. So x is greater than or equal to 0. Okay, and if we have to write our answers in interval notation, okay, remember that this is equal to, which means it's going to be a bracket, and that's where we're starting because it's bigger than 0 or equal to 0. So we start with 0 with a bracket, and this is for the domain. We start with a 0 with a bracket, and it keeps going forever and ever and ever until it gets out to infinity, but we use a parentheses because you can't actually get to infinity. So that's the domain of the first problem. Okay, the second problem, u of x equals the square root of x minus 2. The minus 2 this time is under the square root. So when we set the inside of this greater than or equal to 0, we have to include that negative 2. So we have x minus 2 greater than or equal to 0. If I add the 2 to both sides, that will give me x is greater than or equal to 2. Okay, what that means is that you have to use numbers that are either 2 or bigger. Because if I picked a number that's smaller than 2, say like 1, well, what would happen if I plugged it in here? 1 minus 2 is negative 1, and then I'd have a negative square root, which I don't want. Okay, so that's what this means. And the domain, written in interval notation, would start at 2 and be included because of the line, and it would go to infinity. Okay. This one, we've got 4x plus 12. It's all under the square root. So we will set the entire inside there, 4x plus 12, to be greater or equal to 0. Okay, so first we need to subtract the 12. And adding and subtracting never flips this thing, right? But if you divide or multiply by a negative number, it will flip this thing. Okay, so that becomes 4x. This goes away, 0 minus 12. So we get negative 12. And then it's 4 times x, so we divide by x to get rid of it, right? So here we go. And we've got x is greater than or equal to, let's see, what is negative 12 divided by 4? Negative 3, right? Okay, so that will be our bottom number. It's x is greater than or equal to negative 3. So negative 3 is our smallest number. So our domain would start with a bracket because of the line, the negative 3, and then it would head out to infinity. Okay. Okay, we'll do 3 more fairly easy ones. In my next video, I will go into some ones that have square roots in the denominator. So if you're looking for that topic, check out the next video. Okay, so for this one, we've got 6 minus x in there. So here's 6 minus x is greater than or equal to 0, right? Okay, so we need to solve this for x. So the first thing I can do is add 6 to both sides, which will give me negative x is greater than or equal to 6. Now I need to get rid of that negative that's in front of the x. I can do it by multiplying by negative 1 or dividing by negative 1, whatever. But it will flip this inequality sign because I'm going to be multiplying or dividing by a negative number. Okay, so we'll have to flip it in the next step. So this one becomes a positive x. This flips, and this becomes a negative 6. Okay, so what this means is that x is less than or equal to negative 6. So negative 6 is the biggest number that we can have. So you can't have anything bigger than that, like 0 or 5 or 10, but you can have all the numbers that are smaller than that, right? So your domain is going to be, well, how small can numbers get? Well, they head out towards negative infinity, right? And then as it moves and gets bigger and bigger and bigger until it hits its max, which is -6, and there's a bracket, okay? Let's look at this one. So x plus 5 is greater than or equal to 0. If we subtract the 5, we get x is greater than or equal to -5. Okay, so that domain, the smallest number, is -5 because x is greater than or equal to -5. So we start with -5, and then we head off and we get bigger and bigger and bigger, which means infinity. Okay, one more here. So we get -9x plus 36 is greater than or equal to 0. So let's subtract the 36. That does not flip the inequality sign because we're just subtracting. So -9x is greater than or equal to -36. Now we need to get rid of the -9, which means I need to divide both sides by -9. And since I'm dividing by a negative, I do need to flip the inequality sign. So it'll become x. This switches to less than or equal, and this is 4. Okay, so your domain is all numbers that are less than or equal to 4. And that means less than, if we go to the extreme, would be -infinity. That's definitely less than, and that's the smallest thing you can be. And then the biggest number is a 4 with a bracket. Okay, that's it on that. Stay tuned for the next video that will be involving fractions and radicals.